So let's get it started. A body starts from rest and travels in a straight line for 2 seconds with uniform acceleration of 1 meter per second square. It then travels at a constant speed for some time before coming to rest with uniform retardation of 2 meter per second square. The total distance covered is 15 meter. Then you have to draw and label a velocity time graph. That is the first task. Second, you calculate A, velocity attained at the end of 2 seconds. B, total time taken for the journey. Those are the things we are looking for. So let's start now. Let's draw the diagram. So the first thing, we are going to draw the diagram now. So let's put the diagram in position. Then the velocity will be on the vertical axis and the time taken will be on the horizontal axis. The velocity in meter per second, you have it here. The time taken in seconds. So you start. The body starts from rest. The body starts from rest and travel in a straight line for 2 seconds with uniform acceleration. This is what we call uniform acceleration for 2 seconds. Then you break it down and put the 2 second here. Then we don't have the velocity at this point. On getting here, you then travel at a constant speed that it goes on a straight line. So don't forget you are given the acceleration here, which is 1 meter per second square. Before you now travel at a constant speed for some time, which we don't know. Some time, let's call it X. We don't know that some time. Then it now decelerates uniformly, that is retardation, uniformly to rest. You're given the retardation 2, that is the slope there. Then for how many seconds? Think is for you don't have it. You don't have it. You just come to rest. This is your diagram now. The acceleration, the constant velocity, and the retardation. So you have everything in position. That is the diagram. So you are given the total distance covered. The entire distance covered is given as 15 meter. Then you have to find the velocity attained here. So getting the velocity now, so you need to use equation of motion to solve that. Equation of motion is what you're going to use to solve that velocity that we're talking about. So let's see. So from here to here, let's bring out what we have. We have the initial velocity because it starts from rest, is 0. We have the acceleration, which is equal to 1. Then we have the time, which is equal to 2. So we can use these 3 parameters to figure out what our final velocity is. Then we are looking for u. So when you have UAT and you're looking for v, the formula for doing that is v equal u plus at. Then the u is 0 and the a is 1. Then you have the t, which is 2. When you solve this problem, you're going to have 2 meter per second. That is the velocity attained. It was this velocity that the body maintained for some time. We don't know what that time is. Before the body now decelerates uniformly with 2 meter per second square. This is retardation. The retardation is a negative acceleration. So before you can determine the value of s, we need to come here first to go and figure out this time. Since we have the retardation. Retardation is has the same symbol as a. So you have your a now. From the last part of the journey, from here to here, you have your u, you have your v, you have your a. So you can figure out the time taken there. The time taken is looking for this place. Then our a is 2, since it has to be negative 2 meter per second square. Negative 2 because it's a retardation. The velocity is also 2. You maintain 2 to this level, that is 2. That is slow. So it comes to rest, that is 0. The initial velocity is equal to 2. Then you're looking for the time taken. That is the last part of the journey. Then the same formula should be applied to. V equal U plus AT. The V is 0 this time around. The U is 2 plus A, which is minus 2 times T. I'm looking for that one. Then solving the mass. Minus 2. 2 comes here, become minus 2 equal minus 2T. The minus cancel the minus. Then the time is equal to 2 over 2, which is 1 second. The time taken from here to here is 1 sec. So we have that time now, 1 sec. Don't forget, our target is to determine the total time taken for the journey. So since we have from here to here 2, and from here to here is x, but we have the last part of the journey, 1 second was spent there. Then we can use the formula for total distance cover to figure it out. So let's go there now. So doing that, you apply the formula for total distance cover, which is the area of the trapezium. Total distance cover S is equal 1 over 2 into A plus B times height. You are given the X from the question, 15 meter. Then bring out your A before you proceed. Your A, your B. A and B are the two parallel sides of the trapezium. So let's bring them out before we proceed. From here to here is our A, which we call the X. Then from here to here, the second parallel side is our B. It's going to be 2 plus S plus 1. So if you have a 3 plus X from here to here. Then the distance separating the two parallel sides, that is the height, H is equal to the distance. It's a vertical line. Then we come to the vertical axis. The velocity we got here was 2. Then that is our height. So we can figure out what S is from here now when you substitute every parameter into the formula. So let's go now. Our X was 15 given from the question. Then 1 over 2 into A. Our A is X. Our B is 3 plus X. Then the height is 2. So mathematically, these two stand the chance of canceling these two. That is the mass there. So when the 2 cancel that 2, you can add up what you have in the bracket, then and see what you can do. So we have 15 equal x plus x give us 2x plus 3. That is what it will be. So you cannot add them together. The 3 will come to the other side. We have 15 minus 3 equal 2x. Then we have 12 equal 2x. That is 15 minus 3 give us 12. Then from there, you can divide both over 2 over 2. Then this cancel this. Our x is equal to 6. So if x is equal to 6 now, then you can find it means that x equal to 6. We're going to put it here. The total time taken was 2 plus x plus 1. That's we transform to 3 plus x. Then we have the value of x now. The total time taken for the journey will just now be total time taken now. Total time taken is 3 plus x. And you have the value of x. That is 3 plus 6. That gave us 9 seconds. That is the final answer. That is it. Done. That is it.